Today I thought I'd do something a little bit different and learn about Bevy, which is a game engine in Rust. And I use Raylib a lot on this channel, which is kind of like C mainly. Of course, there's bindings to many other languages, including Rust, but I just wanted to take a look at this thing to see what it's all about, because I keep hearing about it. So I don't know anything. Basically, I don't know anything about it, so we're gonna kind of learn together. So it's a data-driven game engine. I don't know what that means, but sounds promising. Free and open source, I like it. Okay, data-driven, all engine and game logic uses bevy entity control system, entity component system, probably. Custom entity component system. It's fast, it's parallel and cache friendly. Okay, interesting. The fastest, ECS, interesting. Components are structs, systems are functions. Okay. Capable queries, blah blah blah. Log-free parallel scheduler. Okay, sounds very interesting. 2D renderer, render real-time 2D graphics. 3D renderer, interesting. That is not real-time. Probably just an oversight. Compose custom render pipelines using graph structure. That's also kind of interesting. Could probably do some interesting things with like compute shaders and this kind of thing. So animation system, okay, cross-platform, very nice. Bevy UI, a custom UI framework. Built directly on top of Bevy's blah blah blah. Composer is dynamically encoded declaratively. Use a familiar layout thing. Scenes. Okay. Sounds very, very extensive when I also have scenes, like almost like Godot or Unity or something like that. It's not something that Raylib has, at least as far as I know. Sound, of course. Hot reloading. That is very interesting. That is built in. That's very nice. Very nice. Productive compile times. Okay. Fast compiles. That's very nice. Free and open source. Okay. So quick start guide is something. And there's also get started. Maybe that's the same. Okay, it's exactly the same. If you came here because you want to learn how to make 2D, 3D games, visualizations, blah, 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 you came to the right place. If not, stick around anyway, probably will be fun. Bevy is a group of birds. Okay, so already learned something. And it's also a refreshingly simple data-driven game engine built in Rust. It's free and open source. It has the following design goals. Capable, complete 2D and 3D, simple, okay. Simple but infinitely flexible. I like this part in particular. I'm very skeptical. I feel like a lot of engines and frameworks and so on, they really fail on this part. Data focused also sounds good. Modular, replace what you don't like, love it. Fast, okay. Changes should compile quickly, that's very nice. It's built in open volunteers using Rust. Okay, blah, blah, blah. Stability warning. It's still early, important features are missing, documentation is sparse, a new version of Bevy containing breaking changes is released approximately once every 3 months. Okay, so it's not really something that's production ready, but I still think it's interesting to learn. The quick start guide is not a comprehensive guide. Next section will help you set up Bevy and learn the basics, but does not cover most of the features. I think that's fine for now. In the future, you can use the Bevy book. There's a book apparently. Until then, see the next steps, more exhaustive. Or maybe the book doesn't exist yet. Okay, let's get started. It will walk you through the setup of your development, providing a simple Bevy app. If you want to dive in immediately, already have a working Rust app, feel free to follow this quick start guide. Otherwise, move on to the next page. Okay, we already, I think, have Rust. we already have some kind of version of Rust. Why do we have to clone this? That's kind of weird, but okay, try the examples. I guess we can do that. We can just see if there's anything interesting. So let me go in here. I don't really want everything, so I'm just going to do this, and we don't need that many git clones. So apparently that will take some time, and it's just like normal thingy there. And we're on version 0.14. Rust, blah, blah, blah. Creating a bevy project. Okay, now we're ready. It's just a normal dependency. You can either add it, so create a new Rust executable. And that is all good. Okay, so here we get to something interesting, but let's see if this one, it's taking a long time for some reason. So let's go ahead and make the project. Maybe I'll make it in my temporary folder. Just we'll call it like bevy tutorial, and then go in here and we'll say cargo add bevy. And that's also taking quite a while for some reason. Okay, so this one is done. Let's see what we have. Let's get Gmarks and maybe zoom in. And then let's see what we have. Okay, a little bit. So we have some examples. 2D, 3D animation, app, asset, async, audio, camera, dev tools, ECS, games, gizmos, all sorts of stuff. Oh, awesome, interesting. Let's look at app. Let's look at app. So how did they say we should look at this? It was over here. So cargo run example breakout. Okay, so presumably we have to say over here. So cargo run example app. So that's running, downloading a bunch of stuff. This one, okay, this one finished. No example target named app. That's interesting. How about cargo events? So what do we have here? Is there anywhere it says example? Example. Okay, so we can run hello world. We can run, let's try this one. Cargo run example hello world. There's also some like warnings. It requires, so can I do like upgrade? Because I don't have the latest version, apparently. And now we're on the latest, so let's try to run it again. And that failed. For some reason that failed. And there's some kind of crazy thread main panicked. Configure with status code. System library. libudev is okay. So apparently it's not just plug and play. Depending on your platform, you may have to install additional dependencies. Right. So that's probably what we're missing. Yeah, yeah, I think this is the one I don't have, but just for now, let me install this stuff. Okay, so I installed that. Let's try one more time. Cosmic text. Interesting. It seems to be working a little bit better now. It is taking some time. Examples, and I'm gonna try this a little bit later, but let's just get the examples running. Okay, it just says hello world, so that's amazing. How about app? So that's still not a thing. It's still not a thing, but let's see here. So we have example Bloom 2D. Let's try that. So I just has to build that. Apparently we're on the dev version as well. I mean, it makes sense we're on the main branch, but like 0.15, not 0.14, which is the latest release. Okay, that's pretty cool. We can change things here, so we can like decrease the intensity, and I have no idea what all of this stuff is, but okay, we can change things. So that's cool. Yeah, that's not what I want to do. That's pretty cool. Let's see if we have some other examples. Move sprite. This is mostly like good if you want to see how to do something specific, I guess. Changes rotation. Yes. Okay, great. I still want to know what is this app thing, but I guess we will never find out. Sprite sheet, sprite tiles, sprite slides. So all of this stuff, sprite stuff, do we have that in here? No. What if I just search for sprite? Some tests, some stuff in cargo, a lot of examples. So sprites, there's something called sprite sheet in the 2D example, so maybe that's what it's running. Okay, that's cool. That's very, very cool. Let's now finally check out our own thing. So we have cargo here, and let's use 15. Let's see if we can be allowed to use the development version. And here we go. Let's try cargo run. So that didn't work. Maybe we can put like dev, and then we can run it. Okay, so that also didn't work, but let's just use this version then. Okay, no, it's downloading some stuff. Let's just let it do that. So cargo ads, blah blah blah, cargo workspaces, that's forever. Okay. While it may not be an issue with some projects, debug builds in Rust can be very slow. Yes, I actually seen that before, especially when you start using the bevy. It's not uncommon for debug builds to use the default configuration to take minutes to load large 3D models of a frame rate simple scenes. Add the following to your cargo to get fast compilations. All right. So it actually worked. Well, let's try this. Oops, paste. So enable a small amount of optimization in the dev profile. Okay. Enable a large amount of optimization in the dev profile for dependencies. Okay, very interesting. I didn't know you could do that. All right. You might think to simply develop in the release mode instead, but we recommend it against this as it can worsen the development experience by slowing down recompiles and disabling helpful debug symbols. All right. And there's also some release mode optimization, and compile the entire crate as one unit. Do a second optimization as over the entire program. Slows compile times, marginal improvements. Okay, interesting. But I'm not going to use that right now. Enable fast compiles. Bevy can be built just fine using default configuration. Stable Rust. Unfortunately, the compile times are rather long. The section explains how to speed up iterative compiles. Okay. Okay, interesting. So we can compile Bevy as a dynamic library. Okay. Alternative linkers. Then we can use another linker to be faster. And some other stuff. I don't think we're gonna do this right now. Let's try to actually get some code running. And let's just try, oops, not what I want to do. Let's try to go in here and run it again. So now it's compiling everything because we changed these optimization settings, I suppose. So it's taking a while. Let's just let it do that. Every Bevy program can be referred to as an app. Simplest Bevy app looks like this. Okay. Still compiling. And maybe we want to do something like this so we can see both things. And it's really taking some time. Okay, here we go. So we're building all of Bevy again. Okay, I will pause the video now and then I will see you in a little bit. Okay, so it compiled. Let's try again. So now it's pretty fast because everything is compiled. So let's try this thing. Using the prelude, we can go ahead and say Copilot disable, new run. And let's try to run that. So that did not work. It's because it's not this, it's this. Okay, so it ran, but nothing happened, and that's what they say. So you'll notice that nothing happens. That's because we haven't told our app to do anything yet. Okay, so what sort of data does our app really store? We can even do something like, I thought we could, but I guess not. We do have Rust analyzer. We don't have a, it's because I don't have a Rust, I don't know. It's kind of weird. I thought I would be able to see some information. Anyway, looking at docs linked, so there's some linked stuff here, and how do we? Okay, I'm not gonna read all this, but they say it has world, schedule, and runner. World is like the data. Schedule is the systems that operate on this data. So it's like the functions they said before and what they do. And the runner interprets the schedule to control the broad execution strategy. Interesting. You can read more about this by exploring the reference documentation. I feel like this is not really telling me much, but I guess I have to actually read it. Okay, so generally you'll be operating a more granular level than these three basic primitives, controlling data into specific resources or components, and adding systems to an existing schedule. Customize your own app by chaining its methods with the builder pattern. Okay. Initializing resources in the world. First thing we need to do to store globally available data that we only need a single copy of, adding systems to our schedule which can read and modify resources and our entities components according to game logic, importing other blocks of app modifying code using plugins. Okay. All app logic use in bevy uses the ECS paradigm. ECS is a software pattern that involves breaking your, okay, actually I didn't know that, your program up into entities, components, and systems. Entities are things that are assigned groups of components, which are then processed using systems. Okay. For example, one entity might have a position and velocity component. So it's like fields or collision boxes or something like that. So systems or logic that runs on a specific set of component types. So like check for collisions or update position and velocity and things like that. Movement system that runs on all entities with the position and velocity component. All right. It encourages clean decoupled design by forcing you to break up your app data and logic into its core components. Sure. I'm always suspicious when people say it's a clean design, but let's just go with it. Bevy's ECS. Okay, bevy doesn't require anything crazy, it says. So you can create a component like this, like something that has a position. Here is something that operates on a position. Interesting, like query type. So it kind of like it's somehow automatically selects all of your entities that has a position component. And here is an entity. Okay, so let's see how it works in practice. Okay, so they want a hello world function. So let's do that. Hello world. This will be our first system. The only remaining step is to add it to our app. All right. So here we go. Add systems, update, hello world. So this update probably comes from the prelude. And let's try to run it. And it prints hello world once. So that's very nice. So can run, you see hello world printed once. Your first component. Greeting the whole world is great, but what if you want to greet specific people? In ECS, you would generally model people as entities with a set of components. Okay. So actually, derive component, and a person is a component, which is slightly weird. Like, when do we see an entity? But okay. Maybe an entity is just some generic thing. But what if we want our people to have a ECS, you generally model people as entities with a set of components that define them. But then here we have a person, which is a people, a single people, and we call it a component. So I'm already confused. Okay, what if we want our people to have a name? And a more traditional design, we might just tag on a name string field to a person, but other entities might have names too. Sure. So now we have this genius idea that several things might have a name. So we are gonna make an entirely new type that just is a name. We can then add people to our world using a startup system. Startup systems run just once, right when the app starts. Okay. So why don't we try that? So we can have some kind of startup code. So already it's a little bit like you don't really control what's going on. You have to use their system. But anyway, let's try a couple of people. Saying I don't know if these are referring to anything. I'm just gonna accept it. So we have those. Now register the startup system. Okay, that's so we just say it's a startup system, and it's add people. So now we have some people. You could now run this, and the people system will run first, followed by hello world. But our new people don't have anything to do yet. Let's make a system probably greets the new citizens of our world. I'm gonna put maybe, you know, we can have startups here, and let's make a little bit of a macro like this, and then we can have updates, and then we can run our macro, and then we just have the main, and there we go, and then I'll put the updates here, and then we have greet query. It's a query. You need to have a name, and you need to be a person. Weird syntax. So we'll say hello, name. The parameters we pass into system functions define the data the system runs in. In this case, greet people will run all entities with the person and name components. Okay. But what does this with mean? I don't know. And why can't we do this? We just can't. So it's some kind of special type this with. Now we need to register it, and apparently you can say hello world, comma, greet people. Okay. So it's gonna say hello world and then hello world names. I thought, but actually it says hello world last. Is that the same every time? It's the same every time. Okay. Hello world might show up in a different order. That's because systems are run parallel. Okay, so it is actually run in parallel, but it's just for some reason when I run it, it's always the same. There it was different. And it's also different here. Okay. Your first mutable query. If we want to change the names of some people, for example, we can do this using a mutable query. Okay. You know, for being a game engine, it's kind of strange that we don't have anything on the screen yet. We just have some text printing, but okay, I'm not gonna question it too much. Just a little bit. Just a little bit. So we're gonna change a name here, and for the other ones, we're not gonna do anything. We need to make query mutable and use a mutable reference to the components we need to change. Okay, so then we have to add it. And now it will say hello world and update people, greet people, and chain. So it's kind of like a way to ensure that update people is run first. Pretty sure. So we're going to chain it so it runs in the correct order, and I think we need one more of those. Let's try to run it. What? Did I add too many? I don't think so. We have to chain. What's it actually saying? Did I just miss a... Nope. Do I have too many of these? Yes, I have that one. I should not delete it, but this one. Okay. So here we go. So now it has updated it, and we have used chain because we want both of them to run in exactly the order they list. Okay, so we already knew that. Okay, so now what have we learned? We have learned that we have learned that entities are actually components. We have learned that we can spawn things like this. So we say probably the entity type, and then all of the things we want to give it. So we can give it some more stuff. Like we can give it a like nickname, and then we can say, okay, actually this person also has a nickname, which is E. That makes sense. Her name is Elaine. So this guy, he doesn't have a nickname. This person also has a nickname, which will be set and to string, and that should still work. And of course, it doesn't work because I had this n should not be capitalized, and expected argument number 2 of unexpected argument. Right, so it's because of this. Probably have to remove one there. And now, okay, so it works. It just complains because we never use it. But what we can do is, maybe we can say like without, now I'm just guessing, but let's just try it. Without nickname, and then we can query them. Okay, so expect at most 2 generic arguments. So query data, query filter. So it's kind of like a filter. So we have to say and. I'm just guessing again. So that's not it. That is not it. But can we even say without? So let's try that. So we can say that. So name. So query for people with a name, but without a nickname. Okay, but if we had like something else, like a say dog, then we add a dog. He's called Fido, and his nickname is F. Then he will also be printed. He will not be printed, but he has a name. It's because he has a nickname. So we have we're doing without nickname. So we have our dog, and we have a dog, and now he's printed. But so there must be some way of printing, like having multiple things in here, and I just don't know how. That's all right. So we can have another one where we say greet nicknames, and this one is going to be with, well, we can say it's a person, but with a nickname, and then we are going to say, so here this actually becomes a nickname, so we can replace it like this, and greet nicknames. So let's try that. Now we should see some nicknames as well. So we can kind of like, what we're doing is adding this tuple, and it can have a bunch of things. So here we have 3 things, but in principle it could have many more things, I suppose. And that's kind of how we create things, and they are just stored somewhere magical that we don't know about yet. So spawn, we're calling some spawn command that is putting this data somewhere. Okay, that's fine for now. So one of Bevy's core principles is modularity. All Bevy interfaces implements plugins, collection of code that, well, actually, sorry, just bothers me that we cannot say we want to query like and with person, but without. Like, we should be able to do this, but it kind of blows up. So I don't want to do that. I want to see the documentation for Bevy, and I want to see and. So filter combinator combines 2 filters such that span and events enable only if both filters return true. So it looks like I'm missing something. I'm missing something, but I don't know what. Combine 2 so that spans and events are enabled only to be returned. So is that something? This is at the type level, so it doesn't make sense to do and here target filter. How about if we search for the with thing? So it's in the prelude, and do we have anything here? Commands deferred has. There is or, there's or, but there's not and. And how is this one used? Or T. So here we say, it has, that's very interesting. So why don't we try that? You give it like a tuple of things. That wasn't it either. The and equivalent to this filter is a tuple testing query entity or, and we have and. So why don't we do or? Because then we should also still get, so or works, and that gives us, right on here we're gonna say good day. Good day. So these are all the people without a nickname. So that is, who is that? Because it's all. Okay, so we get both persons and things without nicknames. But now we want to do and. Why can't I do and? You know, we try to do and then this happens. Then this kind of. So I need. Am I not in Tmux? Right, I need to run to Tmux. Let's go here and let's say cargo run, and let's see what the problem is. So the and equivalent to this filter is a tuple testing tuple. Okay. Bundle, ref, on add, insert, has, transfer bool, description of entity has. Sure. I feel like this is not the one. We don't want something. And we want, can we search for structs only? So struct. No. Struct struct field. Okay, maybe I can just plain text search for and ECS preload query builder, and maybe this is what we want. No, I don't think so. Okay, I am about to give up. The and is just not found in this. Okay, so and just doesn't think. So weird that you have or but you don't have and. Is there like chain any of? There's not all has. Maybe we can say has and give it a tuple. Has. Now my freaking thing woke up. So let's try to run this. Okay, that also doesn't work. So if I go here, I can see we have or, but do we have and? The and equivalent to this filter is a two. Okay, so I think I finally get it. You just don't do anything. Is that how it's supposed to be understood? So now good day will only say, okay. Oh my God. Okay, plugins. One of the core Bevy's components is modularity. All Bevy interfaces are known as plugins, collections of code that modify an app. Okay. This includes internal features, but games themselves are also implemented as plugins. So a plugin is a collection of code that modify an app. They can pick and choose. Don't want a UI, you don't do that. Want to build a headless service, don't register render. You can replace components, that's fine. Those not going to be back into it. It's released separately are third-party plugins. These are useful and easy to use. Okay, so you can find plugins, which is basically like small parts of your program that someone else has made. There's some default plugins. Let's make our app more interesting by adding default plugins, which are a plugin group containing core engine features. Okay. Default plugins, and I should remove that one. And now let's try to run that. Okay, so that's very interesting. It's running a window, but it's also spamming out these update things again and again. So I guess that's something that the plugins they do. They change the behavior of this kind of stuff. So a window pops up, your console is full of hello messages. This is because default plugin adds an event loop. So the ECS schedule now runs in a loop once per frame. Resolve this in a moment. Okay. So creating your first plugin. So let's try to do that. I think that would be interesting. Let's move our hello logic to a plugin. Okay. So it's a struct that we call hello plugin, and we can make it a plugin. And it's just complaining we haven't implemented it yet. It takes an app and it does things. And then we register the plugin down here. Hello. Okay. Note that add plugins can add any number of plugins by passing in a tuple of them. Now all that's left is to move our system into hello plugin with just a cut and paste. Okay, so we get those, we put them here and run them on the app, and like that. And then that's it. Hello plugins. So now that should just work. It should do exactly the same. So this, I think this is kind of a good explanation of how the plugin works. We have these like different types of systems. Run once on startup, something that is tagged with update. So can we make our own event loop? So how would you even do that? Because this is built, so it would be something like you add a system, an update system that then like triggers update, maybe something like that. So yeah, I don't know. Maybe they will tell us. Try running the app before. All right. The entity and component data systems are great for representing complexity. Actually, sorry. So default plugins adds an event loop. I wonder how they do that. So Panic, this plugin group will add default plugins for a bevy application. Frame count, transform, input, window, asset, lots and lots of stuff. Image plugin. Where is like the loop? I don't see any loop. There's no loop. Is there anything called event? Task pool, log type, frame count. You cannot really have a frame count if you don't have multiple frames. Input window, maybe it's that one. Scene, window init, render, text plugin. I just want to see very quickly. Finish adding this plugin. All plugin, okay. Configures the app to which this plugin. Finished its setup. Okay. So window plugin, window init. So this is actually probably the one that does it. This plugin writes systems that sync with the window init backend and also replaces the existing app runner. It changes the app runner with one that constructs an event loop. Okay, so that's how you do it. There's this default runner that you can change out. So runner add run. Oh, it's app.runner set runner. Okay, and this guy takes a function that runs once and then exits. Okay, so we can actually, let's get rid of that, and then we can set a runner here, and again it's some kind of function that runs once and then returns something. What does it takes? It takes an app, so we can go ahead and say app, and it will just, like, let's say for 0 to 10, let's print that. And can we even do that? So mismatched types, loops. Okay, so we need some kind of type, some kind of return value. What is app exit? So app exit success, we can return that. And this one we're not really using. So now what happens if we run this thing? it will just only do that. But we can also, you can do something like startup, init state, plugin state. How about system, register systems? Add plugins, no, sorry, so startup, there was init state, what is that? Sorry, init state, main mutable init state, and it's calling some kind of init resource, add event. What if we just try to call it? Like, let's just try this. And it needs some generic argument, which is some kind of thing. I don't know what that is. Okay. How can I call these? Can I look at the systems? Is that a thing? Register systems? No. What does this add systems actually do? It does something to main mutable add systems, which looks into resources and no idea what this MUT is, but anyway, it adds with some schedule, it adds the systems. Okay, but how do we get them? So it says main mutable and then self.world. Sorry, so let's go here and let's say add systems. So do we have world? We don't have worlds, but we can say main. Maybe we cannot. Is this kind of private function or something? No, it is a public function. So we should be able to say main mutable. Okay, no method named this thing, because we have to say use bevy app. And still no method named this thing. Bevy, it's because we have to use bevy underscore app. So we do this. And we don't have that, so we have to kind of say cargo add bevy app. And that gave us that. Module app is private. Okay, so we cannot even do that. So let me just remove that one again. Okay, but we kind of see how we can do it. We don't know how to access these things yet, but we can add our own event loop. All right, let's go ahead with the resource. Integer components, data types are great for representing complex variable groups data, but most apps will also require globally unique data of some kind. Okay, so that is a resource. So resource is like time, some assets. Sure, makes a lot of sense. Renderers. By only printing hello once every 2 seconds, we'll be using this by time resource, which is automatically added to our via this thingy. For simplicity, remove the hello world system from your app. Remove the hello world system. Okay, that is the function. So let's get rid of that. And resources are actually much the same way that we access components. You can access the time resource in your system like this. Okay, so greet people. And we say we want the resource called time. And then time, what does time have? How can I get stuff from this guy? Maybe I have to go ahead and look in time. So it has a delta seconds. So can I say delta seconds? And if that one is less than 2, is that what we want? Then we just return. And let's try to run it. So, okay, we cannot add hello world because we don't have that anymore. And there we go. view. So, okay, it's very difficult to see. Let's run it. And that didn't change anything. It's still just printing like crazy. Okay. So I don't know how this works. Maybe time like reset. Time dot 0. Time equals 0. Yeah, you cannot do that. Okay. So let's actually read the tutorial. So now we have the resource. Okay, so we can actually, okay, but let's not do that. So the delta field on time gives us the time that's passed since the last update, but in order to run our system, we must track the amount of time that has passed over a series of updates. To make this easier, it provides the timer type. So we need to create a new resource. I'm just going to put it here. So that's a resource. Okay. And then we can use that. So greet timer. And then we have to do some update here. So we if timer 0 tick time delta just finished. Then we do all this stuff. Okay. So it's going in, getting the timer, and it's probably adding this stuff and just finished. It's because there's some kind of implicit duration that we can set on this thing. Okay, that makes sense. So here we go. Hello plugin. Let's insert a resource. Insert a resource, which will be a greet timer, be a timer with a duration of 2, and it will be repeating. So it will reset itself. Very nice. It's complaining about this because I don't know how it didn't spell it correctly. And now we run it, and it is still like spamming like crazy, which makes sense because we also have this greet nicknames thing. So why don't we remove that? Let's remove it for now, and then we run this code. So good day, and then 2 seconds later it says good day again. Fantastic. Okay, let's add it back in. And do we really want to? No, let's remove it again. And let us get rid of this. And let's format it. And that was that. So next steps. We've reached the end of the quick start guide. If you're hungry for more learning materials, we recommend checking out examples, breakout, assets. Okay, so I think it's a good endpoint for the video as well. Let's make some notes, because what do we want to learn? So UI, how to make UI, and like maybe even before UI, like how do we even like draw a rectangle on the screen? How do we even do that? So UI, we want UI, we want controls, and also we had the we can set the runner app, and it can do stuff. You can say app exit success. And this is return that. So we can do this, but how can we access the systems and all that stuff? So app, world, so there's actually world, and then systems, run system once with, run system with input. So let's try run system, and it can, you have to give it an ID. Where do you get that? So let's look here in the documentation. Run store system by the system ID. Before running a system, it must first be registered. So the method world register system. Systems can be recursive, whatever. So counter 1, counter 2. That's very interesting. So app world system. Let's see, into system set, register system. As opposed to this, what this add system did the register system, did it? Or just schedules, entry. Okay, that's some insane stuff. So how do we, can I, is this crazy? Can you say startup? That was crazy. Okay, run system ID. So how do I get this system ID? It's from this register system, but I'm calling add system. And add system is again changing sub app. Okay. So can I, no, I'm not allowed to access this one. That's what we found out, right? Or maybe I am. So what is this? And what can it do? Register system. Again, we have some systems. So into system set. So what does this mean? It returns something. So can we say x equal app world into system set? And then x, what does x have? It's some kind of thing like that. Can we say for system x? No method name, but I thought that we had this one. That's because it has to be, it's owned. Okay. Yeah, so anyway, back to this. So how do we access systems? And I guess generally like entities, components in a custom runner. I think that's very, like, it's a very fundamental thing that you can go in and you can control the loop and you can control all these things that you add. So I would really like to know that. And yeah, so this is a good set of things. So what else do they have? And here I control something like keyboard, mouse, etc. They say bevy examples is the best way to learn how to use them. So if I click that, where does it take me? Yes, I can run these. Hello world, 2D rendering. So I suppose in the next video we'll take a look at these things. But until then,